This is the fundamental theorem of algebra. The actual statement for the fundamental theorem of algebra is on the second page. That green box at the top. If you want to read through that, you can, but some of y'all, it may confuse you, so I'm just going to explain to you what the fundamental theorem of algebra is saying. We're not going to prove it or anything. Here's an example of using the fundamental theorem of algebra. Example, x cubed plus 2x squared minus 4x minus 6. Use the fundamental theorem of algebra to find the number of complex roots. That should be nothing new. The possible number of real roots, that is new. And the possible rational roots, that is not new. We've done the first and the last. But all those two together all those three together make up the fundamental theorem of algebra. Number of complex roots, you just look at the degree. You know there are 3 roots. Agreed? Because it's a cubic function. Possible rational roots, you do the P over Q test. So the factors of 6 are plus minus 1, plus minus 2, plus minus 3, and plus minus 6. All divided by Q, which is the factors of the leading coefficient, which is plus minus 1. So those are my possible rational roots. And the only new part to the fundamental theorem of algebra is the possible number of real roots. Any odd degree polynomial, you take every number starting at 1 going up to the degree. And those are your possible number of real roots. So if you have x cubed, 1 or 3 are your possible number of real roots. If you had x to the 9th, what would be your possible number of real roots? 1, 3, 5, 7, and 9. Start at 1, include all the odd numbers up to the degree. Okay? If you had x to the 21st, what is your possible number of real roots? 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. Alright, that's if the degree is odd. If the degree is even, you start at 0 and include all the even numbers up to the degree. So if we had a 4th degree, what would be your possible number of real roots? 0, 2, or 4 real roots. That's it. That's all that first example is asking. Okay? So we're done with that question. Alright, now the next example Next example. F of x equals x cubed plus x squared minus x plus 2. It tells you to find all the zeros. We know there are going to be 3 of them, right? Yeah. Because it's cubic. You always start out with the possible rationals. Test those first.
Is find all zeros the same as find all roots?
Yes. So we start out with the P over Q test. P is plus minus 1, plus minus 2. Q is plus minus 1. So we've got 4 possible rational zeros. So let's go back for a second. Let's apply the fundamental theorem of algebra like we did in example 1 and answer those 3 questions for here. How many complex zeros are there? 3. What are the possible rational zeros? We just found that. And what are the possible number of possible real roots?
1 or 3.
1 or 3. That would be it for the first example. But here it tells me to find all of them. So you go to your calculator, get out your calculator. And type into y equals that function. X cubed plus x squared minus x plus 2. So up here. Into y equals. Right there. And when you graph it, you will notice that the only one of the four that we came up with, rational-wise, the only one that looks like it works is -2. So go to your table and make sure -2 works. And you will see that it does work. You see my table up there? It says -2, 0. That shows that it works. Alright? So, now I have to find the remaining 2. I've only found 1 so far. Now find the remaining 2 by using synthetic division. Alright, so the -2 is the one you found to work. Inside the box I have 1, 1, -1, 2. 1, -2, -1. +2, 1, -2. You do get a remainder of 0, which we knew we would anyway. You write this as a quadratic. X squared minus x plus 1 equals 0. We know that this cannot be factored. If it could have been factored, then I would have got more rational zeros, right? So at this point, what's the easiest way to solve any quadratic that can't be factored? Quadratic formula. So that's what I did here, and here are my other 2 answers. So here's one of your zeros, here are your other 2 zeros to that cubic.